Welcome to a series of lessons on concurrency, parallelism, and non-blocking I/O. That's quite a mouthful, I know. And I know that you're as eager as I am to get to some code examples. We're going to do that, but an overview will be very helpful when we hit the code. What you're looking at in my Emacs editor is one of the working files. It's called introduction.txt, and it basically summarizes the points that we're going to cover in this lesson. But I'm not going to read this. Instead, what I want to do is a very quick demo, and I'd like to start with something that's familiar to all of us. So I have my browser open. As you can see, I'm open to the Amazon e-commerce site. And what I'm going to do, just for demo purposes, is come over here and click on this image. And as you can see, the page refreshes, of course, and in fact, I get a different page, and a lot's going on. If we reflect on this for a moment, we can see the things that had to happen in this very short time span. So the time span was, let's say, a couple of seconds. So in that time span, the browser had to respond to a user input, in this case, a mouse click. It had to do some networking, had to go off and fetch some HTML, some images, bring those down. It had to do some parsing of the HTML under the hood, build the so-called DOM, the tree structure. It had to display that tree structure and do some miscellaneous bookkeeping. For example, Amazon needs to remember the last page, the previous page, that sort of thing. So in more technical terms, there are several tasks that Amazon has to perform in the same time span, let's say a couple of seconds, and so it has to support concurrency. So concurrency in this context is simply handling multiple tasks in the same time span. Now, I have a fairly recent machine, my MacBook Pro here. It's got several processors, and what that means is that this machine can perform multiple tasks literally at the same time. In other words, this machine is capable of what I'm going to call true parallelism. So we can take the tasks that need to be done concurrently and farm each of those tasks out to a separate processor and, if possible, do all of these things at the same time. So concurrency and parallelism are related, but they're not the same thing. Concurrency, again, is handling many tasks in the same time span. Parallelism is literally processing many tasks at the same time. So let me return now to my little document. I'm going back to the Emacs editor. I've got a little summary of these points up at the top, and what I'd like to do is move down to this third bullet point and talk a little bit about it. There are two classic ways to manage concurrency. One is known as multiprocessing, the other as multi-threading. For now, I'm going to depend on your intuitions. We'll quickly get to more technical definitions of these terms. Each mechanism supports true parallelism on a multiprocessor machine. So if you have more than one processor, you can do true parallelism. Now, the third component that I want to look at is non-blocking I/O, and this is probably the trickiest one to explain, but let me make a general point which is commonsensical. Of all of the operations performed on computers, I/O operations in general are the slowest. So for example, adding two numbers is relatively fast, but printing their sum to the screen or writing their sum to a file is relatively slow. The idea behind non-blocking I/O is to have a processor not wait for an I/O operation to complete, but rather to start the I/O operation, go off and do something else, and then, depending on the mechanism used, come back later to finish the I/O task. Non-blocking I/O, from a broad perspective, is a way to manage concurrency, but without parallelism. So all three of these terms are related, but they're not identical. I'd just like to make one quick point about non-blocking I/O. It's a little different than multiprocessing and multi-threading in this sense. Nowadays, it's almost always used as a concurrency mechanism in conjunction with one of the other two. So for example, the Nginx web server, which is very high performance, basically uses multi-processing to manage concurrently all of the incoming requests that it gets from clients And it also uses non-blocking I/O under the hood, and this is what gives it some of its high performance. The Node.js framework, which is responsible for a lot of the current interest in non-blocking I/O, has a non-blocking I/O at the API level, and it also has multiprocessing at the API level, but it uses multi-threading under the hood. We'll see examples later that will flesh out these points. So let me try to do a quick wrap-up. Concurrency and parallelism are closely related, but not identical. On a single processor machine, you can have concurrency, but not true parallelism. The good news for all of us in the computer business nowadays is that virtually every machine that we now use is multiprocessor. For example, if you've bought a smartphone within the last 5 years, you basically have a multiprocessor machine. To get a little bit into the jargon, in the bad old days, when we talked about the CPU, the central processing unit, in other words, that architectural unit that contains at least one processor, we were talking about one processor. So people would often use CPU and processor interchangeably. Nowadays, the good news is that at consumer prices, we can get a CPU that has, for example, 2, 4, 8, 16, any number of processors. These are so-called multi-core CPUs. So what we now have is lots of applications that require concurrency, and we have machines that support parallelism. Now, there are uses of parallelism beyond concurrency, and we'll get a look at those. But in the beginning, we're going to focus on concurrency as a challenge, and we're going to look at parallelism as one of the ways to meet that challenge, and non-blocking I/O as yet another way to meet that challenge.